Alright, Chapter 8, Advanced EIGRP. Now, they say this is advanced stuff, but a lot of the stuff we've already talked about, and we've already discussed it in the class, you've already seen it in labs. So you should be pretty familiar with it. Like, we've already summarized routes. We've already done passive interface, that kind of thing. And then we just kind of talk about some of the things that you'll see in EIGRP, like the null interface. So, blah. Here's our network with the EIGRP. You know, we got 172.16 on the left side on R1 and R2, and then we have 192.168 on R3 on the right side. So I got 192.168 on this side, and then I got 172.16 stuff over here, and then I've got an external source to go out. So with EIGRP, depending on your version, you know, EIGRP can do automatic summarization. So it can automatically summarize routes. So going back here, you know, for R3's perspective, it doesn't really matter what he's trying to get to. I guess 192.168.2, 192.168.3, 192.168.1. You could, if you wanted to, summarize all three of those networks as one, you know, 172.16.0.0, and then send them all to R2. And then let R2 handle it if it's going, you know, down here. And that way, R3 only has to have one network with those three locations. So EIGRP is able to automatically summarize those for you, depending on your version. So if you're on version 15.5 or 12.2, I think it is, and there's like it'll come up another slide, automatic summarization is either turned on or turned off. So if it is, I'm sorry, here's the slide. So here on EIGRP, automatic summarization is disabled starting with 15.0 and 12.2. Usually when I see notes like this, I have like a list in my notebook, my 3-ring binder, that has different versions of the iOS. So it'll say, so then there'll be a heading, and it'll say 12.2, 33. And then anything that happens before that, you know, I put in there. So I'll say, hey, automatic summarization is turned on, you know, from this point below. And then automatic summarization is turned off starting at this point. And that way I have it on my notes. And that way, as soon as I go to a customer's router and I do a show version, I see what the first thing I write down is what version of the iOS he has. Then I go check to my notes to see, hey, is it summarized by default, things like that. So it's nice that way. And then again, as far as the CCNA goes, you know they're going to try to slip a question on the new CCNA about automatic summarization since they've changed it. So make sure that you're aware of those version numbers and then where it's turned on and where it's turned off. You know, the 15.0 is easy, the 12.2.33 is kind of tough. So, assuming whatever version you have, if you want to turn auto summarization on or auto summarization off, you go under the EIGRP process. So router EIGRP 10, enter. And then to turn it on, it's auto summary. To turn it off, it's no auto summary. Pretty easy. Now remember, auto summarization means automatic summarization. Do you want the router to do it for you automatically? So if you turn off automatic summarization, you can still manually summarize. It just won't do it for you automatically. So be aware of that point. All right. So remember, your bread and butter command, show IP protocols. As soon as I have an issue and I've identified it as a routing protocol issue, show IP protocols is what I type in. I want to check my autonomous system numbers, make sure they're all the same, to make sure nobody has screwed around with the K values, make sure my network statements are correct, that they match the interfaces, and then in this case you can see whether auto summarization is in effect. In this case, auto summarization is enabled, and we're auto summarizing this, and we're summarizing two components with the metric of blah. Alright, you can also go to your topology table and do show IP EIGRP topology space all links to see all the different links that are available to you. Alright, if you want to check the routing table and you only want to see EIGRP stuff, you show IP route EIGRP. Now I know what you're thinking, hey, well in our lab I can see the whole routing table in one page. Why would I ever only want to see the EIGRP stuff? Because I can just kind of point those three out. Well again, what if you go and work for Time Warner Cable and you're on some, you know, national router that has 5 pages of a routing table. Now you want to find the EIGRP routes. That's why it's show IP route EIGRP. So they show you some of this stuff, and a lot of times you're looking at it, you're like, when would I ever need that? I just do show IP route and see the entire routing table. Well, in class and in small businesses, that works fine. But when you go to work for an international company, that might not work out so well. So you get the idea. So then here it is with auto summarization enabled. So instead of seeing 3, I only see 1. So the way EIGRP handles routes and the routing table, what EIGRP does is it creates a null interface for every network. And then it says, hey, here's the 3 networks that I have. If this is bound for a network and it's not one of my 3, send it here to the null interface. And the null interface is like a black hole. It's like where you want to send things to die, the elephant graveyard. So by default, it creates a null interface in EIGRP, and if a packet does not match in the routing table, it's sent to the null interface so that it doesn't create a routing loop like in this case. So what you'll see is, you'll see your, hey, I'm routing for 172.172.16.00, and I've got 172.16.1, go here, 172.16.2, go here, 172.16.3, go here, and then it'll say at the end of that, 172.16.00, the classful, send to null 0. So when you turn on EIGRP and you got a bunch of networks in there and you start seeing these null zeros pop up, you're like, hey, who created those? They're created automatically, and it's the way EIGRP works to say, hey, if I don't match any of these addresses I have in my network table for this classful network, then go here and die. So it's EIGRP's way of saying die, if that helps. All right, so again, don't forget, you can still manually summarize your routes if you've turned off summarization. And here they say, like, a supernet is an aggregation of multiple major classful network addresses. Really, a supernet is when you take some addresses together, and typically the result is an IP address / subnet mask, and the subnet mask is less than the classful. So like in this example here. Now, here on this third octet, the slide put in 1 extra 0, so they have 1, 2, 3, 4, 5, 6, 7, 8, 9. We know there's not 9 bits in an octet, there's only 8. So forget this very first 0. So I want to summarize 192.168.1, 192.168.2, and 192.168.3. Well, your book always shows you to summarize the whole thing. Hey, make the whole thing in binary. But when you're taking the CCNA exam, sometimes all these steps take up too much time. You only have to summarize, or put in binary, this 1, 2, and 3. The one octet that's different between them. So if I put 1 in binary, 2 in binary, 3 in binary, it goes much faster. And I know the first 16 bits match because they all 3 have 192.168. So the first 8 bits match, the next 8 bits match. So I got 16 bits that match. How many of the third octet do I need to add to 16? So in this case, it's 1, 2, 3, 4, 5, 6. So 16 plus 6 is 22. So I have a new subnet mask of 192.168.0.0/22. And that would match all 3 of these networks. So instead of having those 3 networks in my routing table, I could go to interface blah blah blah, and I could summarize IP summary address, EIGRP1, the autonomous system number, and then the new summary address. And that would summarize the 3 networks that I know about that are on that end. So that's manual summarization. So then to verify, I can always do a show IP route on my routers. Here's one on R1, here's one on R2, and I can see that that network is in there. And then you can also summarize in IP6. So again, we go to the interface, and then IPv6 space summary address space EIGRP space the autonomous system number space the summarized address that we're going to put in. Let's say we're going to summarize, 2001 colon DB8 or 0 DB8 colon and then ACAD colon and then 0000 and then 0001. So remember, the 4th octet is where we subnet. So I can have subnet 0000 or subnet 0001 or subnet 0003. So basically I just double colon and leave that part off, and all those subnets would all match the first 3 quartets. So I'm all summarized. I hope that makes sense. Again, if you have any questions about that, say something in class, and I'll just do it on the board real quick, and you'll be like, oh, okay, that makes sense. It's a lot easier for me because it's going on in my head, and I know what I'm talking about, but it's a lot harder for me to express what I'm talking about. All right, so remember, we can create default routes. So typically when we want to force everybody, hey, if I don't know where to go, send it to here, and let the ISP handle it, we create a default static route. Sometimes it's known as quad 0. So IP space route space 0000 space 0000 space, and then the exit interface 0010. So I created the static route, the default static route, and then I go under EIGRP, so router EIGRP1, enter, and then I type in redistribute static, and then that pushes that default route out through EIGRP updates to my other routers, and that way they'll know that if they can't get somewhere, go here. So I've always remembered it as if it's an open source protocol like RIP and OSPF, the command is default information originate. Which doesn't make a whole lot of sense. But if it's a Cisco proprietary, it makes sense. So then it's redistribute static, if that helps. All right, and then in the routing table, if you do show IP route, you'll find different stuff under D. So remember, D is for dual. EX is an external route coming from another EIGRP domain. So if I have EIGRP autonomous system number 1, and that then connects beside to EIGRP autonomous system number 2, and autonomous system number 2 passes information to me, I'm going to see that as an external route because I'm getting information from a different EIGRP domain. And so remember, by default, EIGRP routes have an administrative distance of 90. But if it's an EIGRP route learned from an external EIGRP domain that's not ours, the route has an administrative distance of 170. So if my neighbor tells me, if somebody in the next city over, the next routing domain over tells me about an EIGRP route, I only give that an administrative distance of 170. But if it's the route I know of my own, then it's a 90. So that's why there are two different numbers in that administrative distance chart. All right, so for IP6, we can also do the same thing. So remember, with IP6, the default route is just :/0. So IPv6 space route space :/0 and space the exit interface 0010, enter. And then IPv6 at router EIGRP2 to turn on the EIGRP process, and then redistribute static. Now, if it's an external route, sometimes, and remember, and we're gonna talk about route redistribution, and it's not a CCNA topic. So what they're saying here is sometimes, depending on where you're pushing this default route out to, you may have to list other parameters so it knows it. So in this case, it's redistribute static, and then we're going to give you a new metric. So we're going to include the metric along with this command, and it's going to have a bandwidth 64. It's going to have a delay of 2,000. It's going to have reliability of 255. It's going to have a load of 1, and it's going to have an MTU size of 1500. So what if I was redistributing that from EIGRP into OSPF or something like that? I may have to include the metrics because they don't kind of convert between the two. You know, OSPF only uses bandwidth, EIGRP uses the 5K values, so that stuff doesn't line up. So I'd have to pass extra information on. Or in this case, if I'm going from one EIGRP network to another network, like EIGRP2 to EIGRP1, things like that. So again, that's beyond really the scope of the course. I don't know why they include that in there, but I just want to explain that. That way, if you saw that slide, you would understand what that came from. All right, now, by default, EIGRP is allowed to use up to 50% of an interface's bandwidth for its messages. So let's say there's some big network who-to-do, you know, some interfaces are going down, interfaces are going up, EIGRP is recalculating, everybody's asking for stuff. It's like, tornado of stuff. It will still, not just the EIGRP messages, will not take up more than 50% of the bandwidth, and that way the other 50% is always free for traffic. Now, I've never had to do this. I've never even heard of anybody ever doing this other than in the book. But you can actually change that if you want to, so that the maximum percentage is something lower, like 20% or 30%. By default, EIGRP does not suck up a whole lot of your bandwidth. You know, we're talking a very small single-digit percentage, if that. And if it got up to 10, I would really be surprised. But I guess on larger, bigger networks, that could be an issue, depending on what's going on in your network and if there's an outage, stuff like that. So you can actually change the percentage of bandwidth that EIGRP is allowed to use with the IP bandwidth percent EIGRP autonomous system number 30. And that would change it to 30%. Works the exact same way with IP6, instead you just put IP6 in front of it. Alright, so remember, by default the hello time is 5 seconds and the hold time is 3 times the hello time, or 15. So in other words, my router and your router are both talking to each other, we're both up, we formed an adjacency, we're both buddies, and then every 5 seconds you send me a hello packet. Hey, hello, hey, hello, hey, hello. Now for some reason the link goes down and I don't get a hello packet. I don't do anything. Now 10 seconds goes by and I don't receive the second hello packet. I don't do anything. When the 15 seconds goes by and I have not received 3 hello packets, then I put a hold on that line. I say, hey, this interface is down. So that way, if the line just kind of like bounces up, like you unplug something, plug it back in, or somebody trips over a cord or something like that, it doesn't make the entire network recalculate the network, and then when you plug it back in, have to recalculate back. So that's the hold time. Hold off on doing anything until this 15 seconds occurs. And that way we know for sure if it's down for 15 seconds, it's probably not coming back up. We're going to need to do something. But if that's not good enough for you, or you want to fine-tune that, you can actually change those timers. But you have to change it per interface. So I go to the interface 0000, and do IP space hello dash interval space EIGRP1 space the new time 60. Now when you update the hello time, the hold time does not automatically adjust with that. So the hold time's not 3 times the hello time all the time. As soon as you change the hello time, you have to change the hold time. So if for some reason you want to, hey, I want to change my hello time to 10 seconds or 15 seconds because I want to eliminate some of the messages going across my network, you can do that. But you'll need to change the hold time too, and the rule of thumb is the hold time should be 3 times the hello time. But also be aware, it'll take longer for your network to make changes if you do that. So by default, after 15 seconds, I mark the route as down and the router start reconfiguring. But if I change my hello time to 30 seconds, then by default I have to wait a minute and a half for a link to be out before my network recalculates. Usually if somebody's on their PC and they can't get to the server or something like, hey, I went to the file server and said no, they back out and they do it again. And then by that time it lets them in. But if I don't know about the route being down for that many seconds, then I don't know. You get the idea. So I digress. But theoretically, it's easier to adjust the hold time first and then do the hello time. As in this case, like as soon as I change the hello time here, IP hello interval to 60, well now hello time and the hold time are the same. So I typically don't want to see that. I like to do the hold time first and then set the hold time first and then do the hello time. But you get the idea. All right, we can also load balance now. By default, EIGRP will do equal cost load balancing on up to 4 links. Meaning, if I have 4 gigabit Cat6 cables from my router to your router, and they're equal cost because they're all gigabit, I can actually load balance between all 4 of those. But if I had more, I have to change the maximum paths value. Now, again, we're talking about big networks with multi-redundancy here. So for some reason, I have 10 equal paths to the same place. So I would have to go into the router config and do maximum paths space 10. If for some reason I wanted to turn off load balancing, I would do maximum paths 1, and then it would pick one and it would use that one. Theoretically the best, but if they're all equal cost, it's just probably going to pick the first one. All right, again, you'd have to be on a very big network with more than 4 paths to a resource. And if you're in a network that big, you need to call me because I want to come and play with it. All right, you can verify that. Like if I do show IP router, show IPv6 route, I can see here that this network is load balanced between 2 interfaces. So if I see more than 1 path or link via in the routing table, it's load balancing. Otherwise, I won't see more than one. So even if I have 3 different paths to get to where and they're unequal, I'll only see one path. It's only if they're equal and I can load balance between them will they show up in the routing table. Otherwise, they're all in the topology table. All right, and then here's the part that I don't know. I've always hated this part, and I've always had to write these commands down because I don't use them very often. You know, banking and medical. When you're in those fields, there are certain things you have to do that are different from everybody else. You know, patient medical records and customer financial data has to be protected, and your reputation as a business relies on that. You know, nobody would go to H&R Block if somebody hacked into H&R Block very easily and they kept losing tax records. Nobody would go to the local hospital if that hospital was always losing their medical records and people were always broadcasting them on the 6 o'clock news. Hey, so-and-so has AIDS. Hey, that kind of stuff. So now we're talking about your reputation as a company. So a lot of companies take that stuff very seriously, and then you have to, even your routers talking to each other internally, they want that information to be encrypted so that if somebody grabs it, they can't rebuild the network and then decide how to get into it that way. So remember, routing protocols like EIGRP and OSPF, EIGRP keeps a partial map, OSPF has a total map of the entire network topology. The entire area 0 is mapped out in there and under OSPF. So if I were able to throw a router on your network and turn him on to OSPF and he were to get a copy of that information, I can then use that to rebuild your network on a diagram, and then I would know the best way to get into it, things like that. So that's when we want to authenticate between routers before we pass information, and that way somebody can't throw a rogue router on my network and do that stuff. You know, with OSPF it's pretty easy to grab, I guess, the information. You know, if you got a PC, you're going to see those hello messages if somebody didn't put on a passive interface. And if I use a routing protocol or a sniffer like Wireshark, I can get into that hello message and see what the hold time, or I'm sorry, what the dead time is, what the hello time is, what the autonomous system number is, what the area number is. I can find that information out from a hello packet. And then if I do that, I can plug that all in my router, plug my router into the network, and I can get that copy. So what we want to do is we want to eliminate that possibility. So we do that with keychains. Hooray! So with EIGRP we use keychains. So basically what we need to do is we need to create a keychain, and then we can create different keys inside the keychain, and then each key has a string or the code of that key. So in this case, you know, I might make keychain Bob, and then this could be key 1, and then the key string will be, you know, Cisco 123. And then I go to the interface and I turn it on for EIGRP. I say, hey, IP authentication, mode EIGRP autonomous system number 1 or 10, whatever it is, and then space MD5. And then, so now I've said, hey, only accept information from EIGRP autonomous system number 10 if it's MD5. And then I go in here and I do IP authentication keychain EIGRP5 autonomous system number, so that he knows to only accept it from this keychain, from keychain Bob. And that way we can kind of work together. So both of our routers have to have the same information. So let me show you what it looks like. So first I got to create the keychain. So keychain EIGRP underscore key. So that's the name of my keychain. And then your keychain can have multiple keys, and you can actually set these to cycle through different keys. You can set time values on keys, but again, way beyond the scope of the course. At this point is you only need to know that I can make a keychain and I can have a key, and here's my key strings. So I got my key chain, and on my keychain I got one key, and that one key has a code of Cisco 123. So that's how I've always remembered it. I can have a keychain. On my keychain I can have a key, and on my key can have a secret code of this. So, and then I can exit. And then I go to my interfaces. So remember, you have to do this for every interface that you want to receive an EIGRP authenticated message. First I have to say, hey, allow authentication through EIGRP, or in this case, force authentication. But if anybody's going to send you anything to EIGRP1, it's got to be authenticated through MD5. And then the second command tells it what source to use to verify that. So hey, I'm going to authenticate on this keychain from EIGRP1, you know, EIGRP key. So this is the keychain I'm going to use. Now, why they separate the word keychain and then the actual keychain name between the EIGRP1, I have no idea. To me, it made more sense if they did IP authentication for EIGRP1 to be keychain EIGRP keychain or keychain Bob. That would make more sense to me. So I don't know who comes up with this stuff, but apparently they're way smarter than me, so they don't speak my language of dumb, so you get the idea. And again, you have to do that with everything. So I got to create the keychain, I got to put the key on it, and then I got to put a code on the key. Then I have to go to the interface and turn on authentication and then tell it which authentication to use. So 5 commands, but 2 of those commands have to be on each interface. Now here it is in IP6. It's the exact same way. Instead of using IP, I use the word IPv6. So again, and actually it works really the same way, exact way. So keychain, I create the keychain, I create the key, and then I create the code for the key. Then I go into the interface and I do authentication, and then I do authentication key. So exact same, it's just anywhere where I use the word IP, I put IPv6 on there. Ooh, before I go to the next slide, make sure you've got a grasp on this for the CCNA. It does come up on the CCNA, especially the new CCNA exam. You'll get 1 or 2 questions. At least one question will have the keychain set up, and it'll say something like, here's 2 different setups. Will these authenticate? Or, you know, what does this command do? Things like that. All right. So again, we always want to verify after we're done. We don't want to just send a packet or something. We want to make sure that everything's working. It's like the guy that goes and fixes the printer, but he never printed it from the user's printer. He just fixed the printer itself. Oh, I printed a test page on the printer. Did you go to the user's PC and do that? So, you know, show IP EIGRP neighbors, show IP protocols, that kind of stuff. All right, troubleshooting EIGRP. So the main troubleshooting commands are show IP protocols. That's your bread and butter. No matter what one you're in, show IP protocols or show IPv6 protocols. That's always the first command that I use. Is EIGRP set up correctly? Am I advertising the right networks? Does everybody have the same autonomous system number? Have I screwed up with the passive interface key? That kind of stuff. Then I go to show IP route. What am I getting? Am I talking to router 1 but not router 2? That kind of stuff. And then show IP EIGRP neighbors. Have I formed an adjacency with those neighbors? All right, they've got their process. Again, if I'm going into a customer's network, I typically start at layer 1 and I jiggle all the cables. Okay, are these cables connected? This cable connected? That kind of stuff. Everything plugged in? Good. I can't, you know, there have been, not too many times, but there have been 2 or 3 different occasions where either myself or another technician has spent a lot of valuable time troubleshooting the network and getting into all these complicated, what's ping, what's traceroute, why isn't this traceroute working, what's digging into the protocol? And basically it's a cord that got tripped on, that got pulled out somewhere. And you feel like an idiot after you've been troubleshooting for 2 hours, and a nurse goes up, hey, this cord's laying here on the floor. Could this be the problem? And you're like, oh no, that couldn't be the problem. I did that automatically. Then you got to wait for her to leave. Then you plug it in, and everything comes up, and you're like, oh, I fixed it. That kind of stuff. So these flow charts and things are very helpful if you can find one that works for you. But either, you know, start from the bottom and work up, or start from the top and work down. But the 2 big things you always want to do, especially when a routing protocol is involved, is traceroute and show IP protocols. Those are the big ones. So show IP interface brief. Do all my interfaces have IP addresses? Are they the correct IP addresses? Is anything administratively down? And I can ping. Remember, ping is different in in ping on the router. And exclamation points are good. Periods are bad. And then, again, the bread and butter, show IP protocols. We've kind of talked that one to death. Show IP EIGRP interfaces. This is nice, so you can see like what interfaces are actually working on EIGRP. Especially if you've got, you know, if you got a 2011 router and he's got 4 cards in there and each card's a double, you know, that's 8 different interfaces you got going out there. So it's a lot easier to sort through those with show IP EIGRP interfaces. And then passive interface. Remember, for sometimes we don't want to send updates or EIGRP updates out a particular interface. If fast Ethernet 00 just goes out to a switch and a bunch of PCs and servers, there's nothing on that network that needs to get an EIGRP update. So I want to do passive interface because I don't want to be passing hello packets out that hole if there's nothing to receive them. So by default, or well, the best practice, Cisco would like you to do everything passive interface, so passive interface default, and then just turn on the interfaces you want. But depending on what somebody does, it's very easy to fat finger one of those. Oh, I turned off 00 instead of turned off 01, that kind of thing. So again, that'll show up under Show IP Protocols. Check your passive interfaces. Hey, for some reason I'm not passing interfaces on serial 00. Oh, that was supposed to be fast Ethernet 00. So if you just want to put on one interface as passive, so it's router EIGRP1. Remember, we do passive interfaces under the EIGRP process. So router EIGRP1, enter, and then what network I'm going to advertise, enter, and then passive interface, serial 0, whatever interface I want to make passive. 9 times out of 10, it's passive interface FA00. If you're missing a network statement, obviously you'll have issues there. So in this case, I got network 10 something that I'm missing. So when I ping, it doesn't show up. But again, I go to my standby, show IP protocols, and that's going to show me the networks that I have. Hey, here's my 2 network statements. Oh, well, there's no network statement for 10, so I'm not going to be advertising that under EIGRP, so that's why it's not getting out there. So then I go back, router EIGRP1, enter, network 10.0.0.0, enter. It picks up the interface, and then it advertises it, and then everybody can ping it, and everything is great in my land. Hooray! All right, and then they give you one last warning about auto summarization. Anytime you have auto summarization turned on, if your network is discontiguous, meaning on router 1 I have 192.168, on router 2 I have 172.16, then on router 3 I'm back to 192.168, I have 192.168, I have a classful address on 2 sides of the network separated by another address. If that's the case, auto summarization can actually be a hindrance, because on R2, if he summarizes 192.168, he may summarize it to point all to R1 instead of pointing some of that to R3. So you'll have issues. So make sure anytime you're working on a customer's network, first thing you always want to do is kind of lay out the network on paper. Hopefully they have a network diagram, and you can see right away, is this network discontiguous? And if it is, I need to make sure that I'm not auto summarizing somewhere that's causing me these issues. All right, after that, blah blah summary, and you get the idea. So in our lab this week, we're going to be playing with EIGRP. We're going to be setting the extra stuff. We're going to change the bandwidth percent so that it only uses like 20% of the bandwidth for EIGRP messages. We'll do passive interface, and we will be summarizing some networks. Hooray! So I'll see you guys in class, and as always, if you have a question on anything that I talked about, make sure you bring it up in class before the lab starts.